Bismillahirrahmanirrahim. Assalamu alaikum to lecture number 11 of CSC 291 Software Engineering 1. In today's lecture, we will be covering activity diagrams, and this will be a formal introduction of activity diagrams, and we will see the UML notation of activity diagrams, what are the elements involved in the activity diagrams, and we will go through some examples. But you need to realize that this lecture on activity diagram is very detailed, and you might not use activity diagrams in that sense, but we will be covering all the notations related to activity diagrams, especially in terms of UML in this lecture. But before we start today's lecture, let's have a quick recap of what we covered in the previous lecture. The previous lecture was about use case diagrams, and it was formal introduction of use case diagrams, although we discussed use case and activity diagrams in the preceding lectures on requirement engineering. But in the last lecture, we covered use case diagrams, and we saw what kind of relationships an actor can have with the use cases, and how we can extend use cases or include the functionality of other use cases in the base use case. So we saw in the previous lecture, we saw that an actor can be drawn either as a stick figure, or we can just have a rectangle and write a keyword which says actor, and this would mean an actor. So for example, if our actor is a student, then if we write student in that box with this keyword actor, then this means that this is an actor in our system. Second thing we saw that each use case is represented as an ellipse, and the whatever the student is going to perform, let's say register course, so the name of the use case is written within the ellipse. And another thing we saw in the use cases, that whenever we draw or start drawing use cases, we need to define the system boundary. The use cases are usually inside the boundary. For example, this register course use case, that will come inside the boundary, and the actors will be outside the boundary, and the interaction between the actor and the use case is represented by a solid line. Now, as I think what we discussed, that giving a direction to this arrow is not important, but if you want, but at times an arrowhead is pointed towards the use case because actor is going to interact with the system. But normally it is not required to show or have an arrowhead when you are trying to represent a normal relationship between an actor and a use case. Then we saw that a use case can be extended. And by extension we mean that there exists another use case, and then we call that use case extending use case. And if we want to extend this register use case, then after the extension this will be called the extended use case. So for example, if there is another use case which is get help on registration, now in this case, if we want to extend the functionality of register course, for example, a student doesn't know how to register a course, he is a fresh student and he needs some help, so we can extend this base use case which is register course by extending the functionality of this use case by get help. So in this case, this particular use case is called extending use case, and this use case is called extended use case. And there are few, and when you are representing this extend relationship, normally it is represented by a dashed arrow, and the arrowhead points from extending use case towards extended use case, and we always write a keyword extend. Okay, another kind of a special relationship that we saw was include. Okay, that include means that if we want to include functionality of another use case, or for example this register use case includes that validity of the student who is trying to register for a course is checked. So here we mean that the register use case would not be complete unless the validity of the student is checked for a particular course he is trying to register. For example, a freshman or a student in the first semester, he would not be allowed to, let's say, register for the final year project, which obviously is offered in the final year of their degree. So if they try to register for that course, then when the validity is checked, then the student would be rejected on that basis. So here, so it's a very key difference that when you have include relationship between two use cases, then include, without the include relationship, a use case is not complete. Whereas in extending, you are just extending the functionality, and even if you don't have extend, then the use case is complete. Another thing we discussed while discussing the use case and the notation, that you can also have the multiplicity relationships when you're representing a use case diagram. For example, we discussed the example of a customer who is trying to withdraw from a bank, withdraw cash from a bank. This is a system boundary, and the bank is on the other side. Now we saw that a customer can have either no transaction or he will have one transaction, whereas at the bank, because the bank can have many customers and it can have various ATMs, so a lot of people can withdraw at the same time from the same bank. So we can also attach the multiplicity relationship, a multiplicity, we can also annotate the relationship with the multiplicity values when we make use case diagrams. So that was it about the use cases that we have covered in the last lecture, and in today's lecture, let's see what we have in store. So first of all, we will have an introduction to the UML activity diagrams. We will see the concepts of actions, pins, and activities, and description of activity nodes and activity edges. We will see some new notations, activity partition, pre and post conditions, send signal action, time trigger and time events, accept event action, interruptible activity region, exception, expansion region, and swim lanes. So basically, it's all about activity diagrams, but towards the end of the lecture, we will discuss swim lane diagrams, and this lecture might be extended. If we are not able to finish these contents in today's lecture, then maybe we will move some of the content to the next lecture. Okay, so the first question is that when to use these activity diagrams. First of all, as we discussed in our lecture on requirement engineering, that whenever we make a use case, then activity diagram is actually a detailed representation of that use case. So the first use of activity diagrams can be that you can use them to analyze use cases. Secondly, it can help in understanding the workflow across many use cases. For example, you have a huge flow where first of all the HR manager, you have made separate use cases for employees and for HR manager, and we are discussing human resource management solution, and the human resource manager, he can basically sign in and then he can generate reports and view the attendance of all the employees, whereas employees, they can just mark their attendance. Okay, now when you are basically you can make an activity diagram which can basically have the flow between these two use cases. So second use of an activity diagram is that it can be used to assess or show or to basically analyze that how the different use cases work together. Or dealing with multi-threaded applications, we can also we will see that how this can be done using the activity diagrams, because there is a concept of concurrent activities in activity diagram, and we can do forking, we can do joining. We will see those concepts, that how activity diagrams can be used to represent multi-threaded applications. Okay, but there are few don'ts for the activity diagrams, and these don'ts say that we should not use activity diagrams to represent object collaboration. Okay? So we cannot make an activity diagram to see that how different objects collaborate. Objects, we mean that different classes that we have, and if we draw different objects from these classes, then we cannot use activity diagrams to analyze their collaboration. And we cannot also use activity diagrams to represent the states of an object during its lifetime. Okay, so activity diagram is not for object collaboration, and it is not for representing object behavior through its lifetime. Okay, Ji. And the second question is, which I think is very important question, and you guys should have thought about it, that where to place an activity diagram. Okay, we saw that use cases is normally the first technical representation of a system, but where does these activity diagrams come in? Okay, you can attach activity diagrams to most model elements in the use case or logical views. Okay. So if you have to put the activity diagrams, then they would be after the use cases, because we saw the uses that we are going to analyze the use cases mainly through these activity diagrams. And activity diagrams cannot reside within the component view. Okay? And if you remember the don'ts from the last slide, because we cannot use activity diagrams to see how objects collaborate or how objects states changes during its lifetime, so they cannot reside within the component view. And this was the where question. Then why make activity diagrams? What do they actually tell you, or how they actually help in analyzing use cases? First of all, they are very effective in illustrating the workflow of the various events in the use case diagrams, because as I told you that what happens that if we keep that human resource manager's problem in our mind, that when he signs in, then he can do multiple things. First of all, if he has forgotten his password, then the things that he would do, or the next actions that he would perform, it would be different if he remembered his password, or if he entered his password correctly. So through making a flow chart, or when we make the flow of actions that a user can perform, we can actually understand the process very well, that what we need to actually implement in a solution to achieve that. Similarly, activity diagram can be used to specify and define each event in a use case diagram. Okay, and what are the steps involved when we are creating an activity diagram? So first of all, what we need to do is we need to identify a workflow objective. Okay, we need to analyze that what this activity diagram is for. Okay, for example, is this activity diagram for the action performed by the HR manager, or are you trying to model the flow of the events that employee would perform, or is it related to report generation? So we need to define the objective. Okay, we need to decide the precondition and the post conditions of the workflow. And third thing that we need to do is we need to identify all the activities and all the states. And fourth thing is define any objects that are created or modified, decide on responsibility for performing the activities, that which active will perform certain responsibilities, we also need to mention that, and connect all the elements on the diagram with transitions. So basically, as we have said, that activity diagram is a flow of events. Okay, and so whenever there is a flow, it needs to be connected. So there should be transition from one state to other state, or one activity to other activity, and we need to place decisions on the diagram. So if there is a decision, for example, in case of authentication, or when somebody enters a password or login, there is a decision that if the password is correct, then do this and this, and if the password is wrong, then take another action. So these decisions, they are also represented in the diagram. And we need to evaluate the diagram for the concurrent workflows, because I have told you that activity diagrams, they support concurrent workflows. So for example, we can do something like that there are multiple activities, and then they can be combined through either a decision box, or we can use what we will see, we can do forking, and then we can do things like that. So basically, we need to analyze our diagram for concurrent workflows. The final thing is that we need to set all actions, triggers, and guard conditions in the specification of each model element. Okay, so we need to be very clear that what do we mean by trigger in the case of this in case of one diagram. For example, by trigger we mean that we will make a transition from certain state to the next state. Okay, so we need to identify those things whenever we make an activity diagram related to certain objective that we have identified in the first step. Okay ji. So now towards the introduction of activity diagrams. So an activity diagram is a special case of a state chart diagram. Okay, it do represent the states, it do represent the events that an actor takes. Okay, but it is a special case of state chart diagram. The states are activities or the functions. Okay, so we can call the main entities in activity diagram. These are the functions that are performed by some actor. An activity diagram is useful to depict the workflow in a system. Okay, for example, you have a system and these are all the functions. So you handle an incident, you document an incident, and you archive an incident. So these are all the activities that a system should perform. So you can see that we have identified that these are the main activities. We can call them the functions, and you can see a workflow that first of all you need to handle the incident, then you need to document it, and then you basically archive it for future references. Okay, activity diagram, it serves as a technique to describe the procedural logic, business process logic, and workflow. Okay, now if you see in this diagram, what we did is you can call it the business logic. For example, if you are a company and you deal with crisis, let's say, and the normal procedure is that first of all you need to handle whatever is the incident or whatever is the emergency, and then you document the whole incident, and then you archive it. So by Through this representation, we actually understand the workflow, that what are the steps involved whenever an incident happens. So for example, this can be a good source for training as well. If you have new employees, you give them these activity diagrams, and they can easily understand the workflow or the business processes that your company is following. It is similar to a flow chart, except that it can also show parallel behavior. Now this is very interesting. As I said, and as we saw in the first slide, that when to use these activity diagram is that they can be used to represent multi-threaded applications. So we need to keep in mind that activity diagrams can also model parallel behavior. And thirdly, activity diagram, this states the essential sequencing rules to follow, thereby allowing concurrent algorithms to be used. Consequently, an activity diagram allows whoever is doing the process to choose the order in which to do certain things. So basically, this is a really advanced form of flowcharts where we can basically have the ordering of the activities. For example, there are 5 or 6 activities which are occurring in parallel, okay, and there is a decision on the basis of which you will either do this or this or this. You can basically control that which activity or which action to perform first. So this is an advanced form of flowchart, and it can be used to describe the actions in a use case. And in terms of software engineering, normally where we use activity diagram is to analyze use cases. So you need to keep that perspective in mind as well. So this is a very simple example of an activity diagram. What we are doing here is that if you see the first function, you can call it a flowchart. Okay, if you guys remember, maybe your first course on introduction to programming, and when you started modeling the pseudocode and you started making flowcharts, then you used to come up with diagrams like that, where you have conditions, and if you have decision boxes, which you represent the if else conditions and stuff like that. So it is similar to a flowchart, as we've already discussed, but it has different purposes and it is extendable. Okay, it can represent parallel behavior. This is the key difference between a flowchart and an activity diagram. So let's go through this activity diagram and see what are the things that are there in this activity diagram. So first of all, we can see that the first function is that we are setting the counter is equal to positive n and set accumulator is equal to initial value. So we have two variables and we are giving them some values. Okay, and then you can see a transition from here to the decision box, and this decision box has a condition that if n is greater than 1, then what we are doing, we basically multiplying the accumulator by n, and we are setting n to n minus 1. Okay, so basically it represents that we have an if condition, and within the if condition, if the if condition is satisfied, then basically it's a loop going on, and we are checking we are multiplying accumulator by n until till n is greater than 1. As soon as n is less than 1, then we will stop doing it. Okay, or n is equal to 1, we will get out of this. Okay, so the next thing we do is we come down and we take a mod of n, and if that is equal to 0, we display the accumulator value. If it's false, then we go back again and we again check the value of n, and if that's fine. So basically you can see that this is a normal flowchart. Okay, we don't have parallel behavior in it. We do have a loop representation, we have decision boxes in it, and you can see different functions here. So, and if we whatever we have seen the different notations in an activity diagram, so we can call this as a function or an activity, and all these arrows, they represent transitions between different states, and these diamond shaped boxes which are like that, they are decision boxes, because we have multiple course of action that we can take once a decision. For example, in this case, we can either go this direction or we can come down this direction. So this is a decision box. So this is a very simple example of an activity diagram. Okay, what are the more uses of activity diagram? They can be useful to specify software or hardware system behavior. So because it's a flow chart, so it is not necessarily only for let's say documenting when you're making a software or analyzing use cases. You can be the use of the activity diagram, it can be extended to hardware as well, and it is based on the data flow model. Okay, it is a representation basically of directed graph, or how data, basically we are representing that how data is moving between different states depending on different actions. So we have activities and there is data flowing between different activities. Okay, so we have a flow chart which actually represents that how data is flowing between different activities. We have a directed graph. Okay, so what's happening, this is another example which basically shows almost all the different kind of elements that can be in an activity diagram. So we have this is called, which you will see in the coming slides, that this is called the starting state, or this is the starting state of an activity diagram. We will actually see the name of that, and these are the activities. So first of all, you receive an order, okay, and then you have a decision box. If the order is accepted, then what you do, you basically fill the order, okay, and once the order is filled, then you have this what we call forking. So you are taking multiple actions here. Once you fill the order, you can do two things. You can either ship the order, or you can send an invoice, and then this invoice represents basically that you're recording that invoice as well, and then you make payment. Once the payment is accepted, so basically you ship the order, okay, and the payment is accepted. Until and unless both of these things they are not occurring, we cannot close the order. Okay, so this is important, that even if you ship it and the payment is not complete, then the order is not closed. So you wait for both the things. So the order needs to be shipped and the payment needs to be successful, and only then you can close the order. And if this decision box represents that if the order was rejected, then you are coming straight away here and then you are closing the order. Okay, and this is the final state of activity diagrams. So basically you can see that there are different kind of constructs here. Number one, we have this solid black circle. So this is one. Then we have something like these, which we call activities. Then we have these arrows. So there are three things. Then we have these decision boxes, 4, and then we have this structure, 5, and then we have this structure, 6. So basically we have 7 different kind of things that we actually saw in this diagram. So let's see what they are and what we mean by them in the coming slides. Okay, before we get to that, let's have some definitions. So what do we mean by a flow in activity diagram? Flow permits the interaction between two nodes of the activity diagram represented by edges in the activity diagram. So basically all the edges in the activity diagram, they are basically flows. They represent flow of data as we discussed between different activities. And what is a state? State is a condition or situation in the life of an object during which it satisfies some conditions, perform some activities, or wait for some events. So we saw that there is data flowing between different activities, okay, but you will see in a moment that what we tend to do is that we tend to wait for certain events or certain set of actions, and only then the data is passed. Okay, so in case of an activity, we are saying that there are different states, and depending on those states, the data is flown between different activities. Then we have type. The type specifies a domain of objects together with the operation applicable to the object, includes primitive built-in types such as integer and string, and enumeration types. So basically we can also specify what type of data is flowing between different activities. So this is something else that we can do. Then there is a concept of tokens. Tokens contain an object, datum, or local of control. So basically whenever there is a flow of data, a token is passed from one activity to another activity. So what does a token would then represent? It can be any data, or we can call it datum, or it's an object, or it is just control. So basically just control. By control we mean that we are shifting the control from one activity to the next one, and it is present in the activity diagram at a particular node. Each token is distinct from any other. So this is something that we need to realize, that each token is different from the other, even if it contains the same value as another. And what does a value mean? An element of our type domain. Okay, so for example, type as we said, in the type we can have integers or strings, and the value of the integer or the string, that is what we mean by value here. Okay ji. So what are the fundamental units of executable functionality in an activity? We call them actions. So what are the actions in the activity diagram? They are fundamental unit of executable functionality in an activity. The execution of an action represents some transformation or processes in the model system, creating objects. So basically the action that, or the transformation process, it can end in creating objects, setting attribute values, linking objects together, invoking user defined behavior, etc., etc. So basically when we have a diagram like that in the activity diagram, basically it's a rounded rectangles, and this is an action. Okay, now this action represents any transformation or process, okay, transformations or processes in the model system, and we usually have a description of these actions. Okay, so we need to write something in between. For example, in this example there are two actions. First one is send payment, the other is accept payment. Okay, So when we are sending payment, then obviously something would be created. Either it will be control information that will be sent to accept payment, or there would be some object or some value or something would be sent from here to here. Okay, so basically by sent payment, it's not just a box. We are trying to represent that this is an action, and this will result in some kind of a value that will be passed to accept payment. Okay, then comes the concept of pins. Pins is very interesting. That what do we actually mean by pins? That each action that we perform, there is a pin associated to it. Okay, so for example, we have this box which represents an action. Okay, so let's do it again. That let's say we have this box. So we need to be very careful with the boundary here. So we have this box. So this represents an action, as we discussed or we saw in the last slide. Then we can have these small boxes attached to these actions, and we call them the pins. Okay, so what do these pins are for? These pins basically store the values or the data or the control information that is being passed to the next activity. Okay, so let's go through what we have written in the slide, that actions can have inputs and outputs, and these are basically through these pins. So you can call them the interfaces between different actions. Okay, the pins, they hold inputs to the actions until the action starts, and hold the outputs of the action before the values move downstream. So for example, in case of fill order, once the order is filled, then the order is stored in this particular pin. Until the order is passed to ship order, the order will remain here. Okay, so this is something really interesting, that we are basically holding order until it is being passed to the other activity. And similar is the case that at the input end, for example, for this particular action, ship order, this pin will hold the order, okay, till this action starts. Okay, and what about the naming of these pins? It is not restricted. Okay, generally they are basically what type of value they store, we call them with that. Okay, for example, in this case we have name, and in this case we have order, because these pins were storing order, so we call them order. Okay, so there is no restriction on naming these pins. Okay, what we can do with the pins is we can have this special kind of notation as well. We can create those standalone pin notations. For example, it is the same thing that we have here, that we have these two actions, and what we have done, because there was a common pin, both these were sharing the name, so we can have a structure like that. We have a box and we write name within it. So this is actually representing the same thing that we have here. Okay, this is just a different notation. So you understand the concept of pin, that these are kind of the interfaces between different actions. So for example, there is an outgoing data from an activity. The pin would hold the data unless till the data is passed downstream or towards the next action. Similarly, the pin will hold the input pin will hold the data until the action starts. Okay, so this is the concept of pins. Now we do have some special kinds of pins. Okay, and first of all, we look at streaming parameters. They are usually notated with this word stream. Okay, they accept or provide one or more values while an action is executing. So basically, by stream we mean that the information is actually continuous. Okay, and the action is actually performing, but there is something going out of that action. Okay, so for example, in this case we have generate leads, and we have lead here, and then we have follow leads. Now this is a stream because this activity is continuous. Okay, and you are getting leads continuously, so there is a stream of information that is going from this pin to this action to this action. So we have a continuous data going from one end towards the other end. The other type of pin is exception output parameters. They basically provides values to the exclusion of any other output parameter or outgoing control of the action. The action must immediately terminate and the output cannot quit. Okay, so for example, in the case of accept payment, okay, if the payment is accepted, then you basically come to this credit account. Okay, but in case it is not, then you basically send the rejection. Okay, so they basically are special case when you need to end the action, or you need to basically exclude certain parameters. So basically what do these exclusion, and the exclusion is normally represented by this small triangle. Okay, so what does it do? We'll look at it again. It provides values to the exclusion of any other output parameter or outgoing control of the action. So basically this would have a certain value जिसकी basis के ऊपर you are sending the rejection. Okay, so we saw there are two different kinds of parameters. One is stream and the other you can basically send the control information जो कि आपको ये बताती है कि ये output किस वजह से reject हो रही है. Okay जी. Okay, then we can have special pins which would basically combine to make a set of parameters. Okay, so for example you have this big action which is basically called order, and then input there is a small pin. But when you are filling an order, then you have two kinds of information. You have the package and you have the paperwork. So you can see there are these two small pins, but they combine to make a big set. So we can call it parameter set. Okay, and in case of partial product we have again two sets. Okay, so what it does, it's a group of parameters. The actions can only accept inputs from the pins in one of the sets. Okay, and the action can only provide outputs to the pins in one of the sets. So this is something that we need to keep in mind, that for example this fill order is linked with another action. So if this is linked here, now this particular action, whatever that would be, that can only accept input from either this set or this set. Okay, another special kind of pin which we call it value pin. Okay, it's a special kind of input pin defined to provide constant values. Okay, so for example there is an action and there is some calculation going on. For example you are using pi in a certain formula. Now we know the value of pi is a constant, is 3.1416 whatever. So there is a constant value that will be used by this action in the computation. Okay, so whenever that is the case, then you can have these value pins with the other pin. Okay, so these two will be combined and that certain action is performed. So we call them value pins. Okay, so we saw there are four kinds of pins. Number one is streaming parameters. These pins are used to represent streaming parameters. Then we have pins to represent exception output parameters. Then we can have pins to represent parameter sets. Then we have pins to which hold constant values. So there are four different kinds of pins. Okay ji. And what are the conditions to start and end the actions? Okay, an actor or an action can only start if all non-stream inputs have arrived. Okay, this is very interesting, that we saw that there are streaming inputs, and we discussed the streaming input is something that is continuously coming, and the action that is waiting for that streaming input, that cannot wait. So whenever he receives the input, because it's a continuous process, तो काम चलता रहेगा. Okay, whereas if it's a non-streaming input, तो जो next action है वो उस वक्त तक start नहीं होगा जब तक कि उसको पूरी input receive नहीं होगी. Okay, for example let's have a very simple diagram, something like that. There is a pin here and there is a pin here, और यहाँ से एक और activity. Now this action will not start unless this pin receives all the data. Okay, and when does an action finish? The action can only finish if all the inputs have arrived, streaming inputs included, and all the non-stream and non-exception outputs have been provided. So for example, if in case of this diagram, if this was accepting some inputs and it is producing some output as well, so we can only say that this action is complete, or we've gone through this action, or this action is finished once it has received all the data, if it was receiving some streaming parameters, and if it has produced all the data. Only then we will say, if these pins are empty, then we will say that the action is done or the action is finished. And how do we prevent deadlock? An input pin of an action cannot accept tokens until all the input pins of the action can accept them. Okay, so if there is an action which has multiple input pins and they are holding some values, and so basically they cannot accept more inputs, so the other pins, they would not accept any other input. So they will wait for those inputs to be processed, and then they will start accepting new. So that's how we prevent, or we basically represent that's how deadlock is prevented using in an activity diagram. Okay ji. Now let's have a look at these activities. An activity, what is an activity? An activity is the specification of parameterized behavior as the coordinated sequencing of subordinate units whose individual elements are actions. Okay, so basically if we have a huge, these are basically all activities. Okay, and then we have input parameters and we have output parameters. Now within an activity there are different actions that are taking place. Okay, so we have seen what actions are and we have seen what activities are. So activities is basically group of those actions. Okay, so what does the activity do is within an activity there can be multiple actions. So we need to understand that this represents these represents the activity nodes and these represent the activity edges. Another thing about activities is that an action can invoke an activity to describe its actions more finely. Okay, for example, when you have filling order, then you can have an additional activity which actually describes that what the order is. Okay, so you can have basically an activity which or an action which will describe that how to fill the order. Okay, so we can have that when we are making these activity diagrams. Okay, so these are the different kinds of, there are 3 different kind of nodes in an activity diagram. The first one we call them action nodes. Okay, and we represent them by this rounded rectangle. Okay, what do we mean by action nodes? They are executable activity nodes. The execution of an action represents some transformation or process in the model system. Okay, so basically these are the ones which would process some input and then produce some output. Then we have these control nodes. Okay, and there are different kind of control nodes. What do these control nodes do? They basically coordinate the flow of information to certain actions or to those action nodes and from certain action nodes. Okay, so these diamond boxes, I already told you, we call them the decision nodes or the merge nodes. Then we have these fork nodes. What do they do is basically if there are multiple inputs coming in and we need, if there is one input coming in and you need to pass it to multiple, then we can use these fork nodes. And similarly the same symbol is used for joining nodes, and where its function is basically the opposite, where you are basically waiting for multiple inputs and then you're producing some outputs. So the same symbol is used for forking and for joining. Then we have this solid circle, we'll call it the initial node. Okay, so this is where the activity diagram starts. And then we have these states which we call them activity final states, and then this is the flow final where the complete flow finishes. Okay, then we have some object nodes. What do we mean by an object node? It indicates an instant of a particular object may be available at a particular time in an activity. For example, we have seen that an activity diagram, what we are doing, we're doing different actions, and depending on that some data it produces or the values are changing. Okay, now we can create these object nodes which represent the state of an object at a particular time. Okay, so we do have object nodes, and basically the pins that we have seen, they are the object nodes, because we saw that the pin, they hold certain values at certain time. So हमारे पास we have these activities और उसके साथ जो pin attached हैं, they are basically the object nodes. और हमने देखा था कि पिन बनाने का दूसरा तरीका क्या है कि we can have these activities, उसके बीच में हम एक पिन भी बना सकते हैं, and then we have another activity. So this is object node. It holds some parameters or it holds some values of those parameters or objects. Okay, then we have activity edges. All the activity edges, they are directed. Okay, as we saw in one of the slides, that this is a kind of a directed graph where all the actions, they are directed. There is always a direction from one action to another action. They always have a source, they always have a target. For example, in this case, this is the source and this is the target. And on these edges, the tokens flow. Whatever the information is, it will flow basically on these edges. Okay, and any number of token can pass. You know, you can the thing is that we can also set some restrictions कि कितने token इसके ऊपर pass करेंगे. Okay, for example, and you can assign weight. जब आप weight assign कर देंगे तो उसका क्या मतलब होगा कि सिर्फ इतने token maximum pass कर सकते हैं. For example, this particular activity diagram, it represents कि आप cricket की team बना रहे हैं. Okay, तो क्रिकेट प्लेयर कि ये वाली है ऑब्जेक्ट नोड. ओके, दिस इज एन ऑब्जेक्ट नोड कि यहाँ पे क्रिकेट प्लेयर है, एंड देन यू आर बेसिकली पासिंग इट टू दिस सेक्शन विच सेज फॉर्म क्रिकेट टीम. तो इसका वेट हमने 11 स्पेसिफाई कर दिया. इसका क्या मतलब है कि देयर विल बी ओनली 11 टोकन्स गोइंग फ्रॉम हेयर टू हेयर. ओके, एंड व्हेन यू असाइन द मैक्सिमम वेट, उसकी वजह से क्या होता है कि बेसिकली व्हेन यू आर फॉर्मिंग अ क्रिकेट टीम में 12 खिलाड़ी तो हो नहीं सकते, सो दे बेसिकली रिस्ट्रिक्ट कि मैक्सिमम टोकन्स एक ऑब्जेक्ट नोड से दूसरी एक्शन के अंदर कितने जा सकते हैं. ओके, सो वी कैन हैव दीज रिस्ट्रिक्शंस ऑन एजेस. Okay, we do have two kinds of edges. One we call control flow edges and the other we call object flow edges. Control flow edges क्या करते हैं? They just represent the control transferred between two actions, whereas जो object flow edges होते हैं वो actually information लेकर जा रहे होते हैं. और object flow edges जब भी होंगे they will be between object node and an action. ठीक है, जिस तरह ये वाली जो example है, this is an example of a control flow edge which is directly between two activities. And very simple kind of activity diagrams which you would normally see when you use them to analyze use cases, then they would have these control flow edges जो कि सिर्फ बताएंगे कि एक एक्शन से आप दूसरे एक्शन में कैसे जा रहे हैं, how the control is transferred. Whereas these object flow edges, they whenever you make them there would be object nodes involved. ठीक है, क्योंकि these are the ones who are actually sending some actual data. ठीक है, ओके जी. नाउ देयर वी डू हैव सम ऑप्शंस कि ऑब्जेक्ट नोड्स के अंदर हम मल्टीप्लिसिटीज भी रिप्रेजेंट कर सकते हैं, एंड वी कैन रिप्रेजेंट द अपर बाउंड, वी कैन ऑल्सो ऑर्डर देम. ठीक है, कि कौन से ऑर्डर के अंदर हम डाटा पास कर रहे हैं. सिमिलरली एक्टिविटी नोड्स वी हैव प्रेजेंटेशन ऑप्शंस एंड ट्रांसफॉर्मेशन. We can do some selection and we can do token computation. ठीक है जी. Now these are the different options when we are making activity diagrams. Whenever we have object nodes, तो हम multiplicity जो one to many इस तरह के relationship है we can show that. Similarly, in case of activity diagrams, we can show transformations, or we have different presentation options. We'll see what they are. And similarly, we can do some selection options, or we can represent token computation within an activity diagram. We'll see some new notation in the coming slides. How do we partition activities? How do we represent pre and post conditions? How do we send signal action, time trigger and time events, except event action, interruptible activity region, exception or expansion regions? We will see all them. Okay, this is another example of an activity diagram, and if you see, this is kind of a detailed one. Okay, now you see that this is the starting state of this activity diagram or of this flow. Okay, and the goal is that you are going to some place which is called de novo. Okay, so what you are doing, first action that you are performing, you are saying you get your luggage ready. Okay, now when you have your luggage ready, there is a decision box. Either you are going on car or you are going on train. You can have another action which might say that you are going on a plane. So based on the car, the set of actions would be totally different. So these are the set of actions that you might perform if you are taking a car, and these are the set of actions you might perform if you are going by train. Okay, so the first thing when you decide to go by a car is that you turn on a car. Okay, so if the car is on and the tank is full, you basically fill up with fuel. Okay, and then you come to another decision box. Okay, so if the tank is full, then you say that the tank is full, and you come here, you go to the motorway toll gate, you get the ticket, you exit to Geneva toll gate and pay the ticket and go home with the car. Okay, whereas if you are here and the tank was not full, the first thing that you will fill the tank, and then again you will wait at this decision box, then you go to motorway. So this is in this we are actually representing just the control flow information, that how we are moving from one action to another action depending on. And we have some decision boxes here जो कि हमें बता रहे हैं कि क्या अगर एक्शन होगा तो उसकी बेस के ऊपर हम क्या एक्शन करेंगे. फॉर एग्जांपल, इफ आपने गाड़ी ऑन की और टैंक फुल नहीं था, तो द फर्स्ट थिंग यू विल डू, यू विल फिल अप द कार, और अगर टैंक फुल था देन यू विल डू समथिंग एल्स, यू विल बेसिकली स्ट्रेट अवे गो टू द मोटरवे. ओके जी. नाउ इफ यू आर टेकिंग अ ट्रेन, देन व्हाट यू विल डू, गो टू द स्टेशन. ओके, एंड हियर व्हाट वी हैव इज this is called forking. Okay, and you are basically doing two things here. You will buy the ticket, okay, obliterate the ticket and catch the train, okay, and your friend, what he would do, who has actually dropped you to the station, he will go home. So basically for the friend, the flow actually ends here. Okay, so these activities, they are occurring in parallel. Okay, so this is what we meant earlier जब हमने कहा था कि we can represent parallel behavior in activity diagram. So here is the parallel behavior, that there is somebody who has actually dropped you at the station, Now you have to actually buy the ticket and board the train and travel wherever you're going, but your friend who has dropped you, he needs to go home. तो उसका flow भी आप दिखा रहे हैं कि the flow is finished for him. And what you're doing, you come here and you basically, there is a decision box here. What you're doing here is you basically wait for some time, okay, and if you realize कि अभी आपके पहुंचने में बहुत टाइम पड़ा है, okay, then you keep on reading, but else you get off the train, okay, आप वेट करते हैं, ठीक है, और ये एक्चुअली रिप्रेजेंट कर रहा है कि आप एक्चुअली बस कुछ देर वेट कर रहे हैं, ओके, एंड दिस इज एक्चुअली ज्वाइनिंग, ठीक है, कि आपका टाइम थोड़ा रह गया पहुंचने में एंड यू आर वेटिंग, व्हेन यू एक्चुअली गेट देयर तो आप यू गेट ऑफ द ट्रेन, यू गो होम विद द बस, एंड दिस इज वेयर योर फ्लो ऑल्सो एंड्स. सो इस एक्टिविटी डायग्राम के अंदर यू कैन सी कि वी हैव ओनली रिप्रेजेंटेड द कंट्रोल, कि आपका फ्लो कैसे हो रहा है इंफॉर्मेशन का, ठीक है. ओके जी, नाउ वी डू हैव, जो हमने नोड्स अभी आपको हमने पीछे डिस्कस की थी कि हमारे सिस्टम के अंदर 4-5 तरह की नोड्स होती हैं. कुछ हमारे एक्टिव एक्शंस होते हैं, फिर कुछ हमारी डिसीजन बॉक्सेस होते थे, फोर्क, जॉइनिंग और कंट्रोल नोड्स. लेट्स सी व्हाट दे आर. जो हमारी कंट्रोल नोड्स होती हैं इनका बिहेवियर क्या है, ओके. In an activity, the flow starts in the initial node that returns the control immediately along their outgoing edges. So, for example, इस पिछले वाले केस के अंदर ये हमारी initial node थी, ठीक है, और we can call it the control node. Control node इसे क्यों कह रहे हैं? क्योंकि ये control सिर्फ पास करती है, ठीक है. It is passing the control to the outgoing edges. Okay. So, इस केस के अंदर what this would do, this will just pass the control to this receive order action or receive order activity. Now if there are more than one initial nodes, a control token is placed in each initial node when the activity is started, initiating multiple flows. Okay, यानी कि for example, if there are 2 control nodes, ठीक है, तो a token is placed, a token would be placed with both of them, ठीक है, which might initiate multiple flows, ठीक है. And secondly, if an initial node has more than one outgoing edges, जो कि हमने इस केस में देखें कि जो हमारी initial node है, it has more than one, it has basically 2 outgoing edges. Only one of these edges will receive the control because initial nodes cannot duplicate tokens. Now this is something very interesting कि आप initial node से अगर 2 outgoing edges हैं तो you would do one thing. You cannot basically do A and B, you will do A or B, ठीक है, because these control nodes or these initial nodes, they cannot duplicate these initial nodes. Especially this is a type of control node, but this initial node, they cannot duplicate tokens. This is something that we need to keep in mind. Okay जी, फिर हमारी दूसरी type of control nodes क्या है? We call them decision nodes, जिसको हमने कहा था कि we usually represent them with these diamond boxes. Okay, what do they do? They route the flow to one of the outgoing edges, ठीक है, and again tokens are not duplicated. Okay, guards are specified on the outgoing edges or with the stereotype decision input. There is also the predefined guard for guard else, यानी कि हर decision box का एक else होता है और एक true condition है, यानी कि if this happens then you go this and else this is some predefined guard. यानी कि इस केस के अंदर आप देखें तो इस डिसीजन बॉक्स के गार्ड्स हमने खुद डिफाइन किए हैं. देयर आर 2 गार्ड्स. वन इज इट सेज के या 2 तरह के डिसीजन है. गार्ड का मतलब है देयर आर 2 काइंड्स ऑफ डिसीजन, आइदर द ऑर्डर इज एक्सेप्टेड और द ऑर्डर इज रिजेक्टेड, ठीक है. बाय डिफॉल्ट वी डू हैव एन एल्स, ठीक है, यानी कि इफ फॉर एग्जांपल द ऑर्डर इज रिसीव्ड एंड इट इज फुल, तो आप इधर फिल ऑर्डर कर देंगे. अगर कोई मसला है तो आप यहाँ पर चले गए. तो देयर इज ऑल देन इफ एंड एल्स, दे आर ऑलरेडी प्री डिफाइंड. इफ ऑल द गार्ड्स फेल, अगर फॉर एग्जांपल ये दोनों फेल हो जाते हैं, ठीक है, द टोकन रिमेन एट द सोर्स, ठीक है, unless and until इन दोनों में से कोई से एक्सेप्ट कर लेते. फॉर एग्जाम्पल यू आर कीपिंग और रिसीविंग ऑर्डर, यू कैनॉट डिसाइड वेदर टू रिजेक्ट इट और टू एक्सेप्ट इट, देन यू विल कीप until एक ना एक गार्ड इसको एक्सेप्ट कर लेता है, एंड देन यू विल मूव ऑन. ओके, ओके जी. सो हियर इज वेयर यू आर टेकिंग दिस decision. ये एक एग्जाम्पल है जो हमने अभी पीछे डिस्कस की है. ओके, एंड देन देयर इज एन एक्शन विच इज ओपन इंसिडेंट. इफ इट्स अ लो प्रायोरिटी इंसिडेंट, then you will allocate resources to it, ठीक है. If it's fire and high priority, notify fire chief और आप उसको resource allocate कर देंगे. If it's not fire and high priority, notify police chief. So you basically you can see कि आपके इस डिसीजन के ऊपर मल्टीपल तरह के अब आपके गार्ड्स हैं. पहला गार्ड क्या है कि लो प्रायोरिटी है, दूसरा गार्ड है आपका हाई प्रायोरिटी और फायर है, और तीसरा है कि फायर नहीं है लेकिन हाई प्रायोरिटी का इंसिडेंट है. इन केस ऑफ फायर यू विल टेल द फायर चीफ, आप उसको रिसोर्स एलोकेट कर देंगे. इन केस ऑफ हाई प्रायोरिटी एंड नॉट फायर आप पुलिस को नोटिफाई करेंगे, देन दे विल एलोकेट रिसोर्सेज. अदरवाइज इट्स लो प्रायोरिटी यानी कि कोई छोटा मोटा इंसिडेंट है तो यू विल जस्ट ट्राई टू एलोकेट रिसोर्सेज. ओके, लेकिन एक चीज़ जो हमने कंट्रोल नोड जो डिसीजन नोड्स हैं विच इज़ द टाइप ऑफ कंट्रोल उनके बारे में देखी कि दे ऑल्सो कैन नॉट डुप्लीकेट टोकन्स. ठीक है, यानी कि वी आर नॉट डूइंग कि हम इन तीनों के ऊपर एट अ टाइम आ रहे हैं. वी आर सेंडिंग वन टोकन एट अ टाइम. फॉर एग्जाम्पल यहाँ से एक टोकन आया और वट एवर दैट वॉज वी सेंड इट आइदर हेयर और हेयर और हेयर. सो दे ऑल्सो कैन नॉट डुप्लीकेट टोकन्स. सो देयर विल बी जस्ट वन एक्टिव आउट गोइंग एज फ्रॉम these decision control nodes. Okay, then we can also use these diamond boxes for merging nodes. Okay, so what do? They basically bring together alternate flows. जिस तरह अगर आप इस केस के अंदर देखें तो what they are doing, they are bringing together these alternate flows. For example, आपको ऑर्डर रिसीव हुआ, अगर ऑर्डर एक्सेप्ट हो गया तो आपका फ्लो यहाँ पे आ रहा है, अगर रिपेयरेबल था तो यहाँ पे आ रहा है, आपने ऑर्डर को मॉडिफाई एंड देन इट्स बेसिकली वेटिंग. तो यहाँ पे इसका रोल क्या है? इट इज बेसिकली मर्जिंग. ठीक है, वेयर इज हियर इट्स डिसीजन. ठीक है जी. ऑल द कंट्रोल्स एंड डाटा अराइविंग एट अ मर्ज नोड आर इमीडिएटली पास टू द आउटगोइंग एजेस. ठीक है, यानी कि जो भी आपको डाटा यहाँ पे रिसीव हो रहा है वो फौरन आप फिल ऑर्डर को पास कर देते हैं. ओके जी. देयर इज नो सिंक्रोनाइजेशन ऑफ फ्लोज और ज्वाइनिंग ऑफ टोकन्स. दिस इज समथिंग वेरी इंपॉर्टेंट कि जब भी आपको सिंक्रोनाइज करना है, ठीक है, फॉर एग्जाम्पल आपकी ये मल्टीपल इनपुट्स आ रही हैं, ठीक है, लेकिन जब आप ये वाला नोड यूज़ करेंगे तो वट एवर इनपुट इट्स गेटिंग इट विल पास इट ऑन टू द आउटगोइंग एजेस. ओके, वेन एवर यू आर यूजिंग इट टू मर्ज इनपुट्स. और जो आपका आगे एक्शन होगा वो उसकी रिस्पॉन्सिबिलिटी होगी कि वो उस इनपुट को एनालाइज करे कि क्या इनपुट आई थी और व्हाट डज इट मीन. वेयर एज इफ यू वांट टू सिंक्रोनाइज द फ्लो ऑफ के आउटपुट किस वक्त जानी चाहिए, देन यू कैन नॉट यूज इट. फिर we will see what do we have to use. We will have to use basically join, which we have already seen. So let's wait till we actually get to that. Okay ji. Now this was one of the key things that we discussed that differentiates activity diagrams for normal flowcharts, that we can represent parallel behavior using activity diagrams. So we can use activity diagram to synchronize multiple activities. Okay. So we can also use it to split the flow of control into multiple threads. So for example, we have an open incident here जो हमने पीछे एक this the same activity diagram that we are trying to represent there. So what we are doing here is that we are actually splitting. ठीक है. So whenever it gets here, so we are trying to split the action into three possibilities. We allocate resources, we coordinate resources, and we document incident. So basically these three actions are started and we are representing some parallel behavior. Lekin here again what we are doing, we are actually synchronizing. So we will wait for all these to complete and then we will archive the incident. Okay, so अगर तो हमने यहाँ पे ये वाला बॉक्स यूज किया होता जो कि हमारा डिसीजन वाली शेप वाला बॉक्स था, डिसीजन वाली शेप की नोट थी, अगर हमने ये यूज़ की होती तो व्हाट दिस वुड हैव डन कि एज सुन एज यू एलोकेटेड रिसोर्सेज तो वो आर्काइव के पास हो जाता और जैसे ही आप रिसोर्सेज को ऑर्गेनाइज कर रहे होते उसका डाटा भी यहाँ आ रहा होता और आप डॉक्यूमेंट करते वो भी आ जाता. लेकिन ये सिंक्रोनाइजेशन ने क्या किया कि दिस विल मेक ऑल दीज टू वेट. जब सारे आ जाएंगे देन इट विल बी पास टू आर्काइव इंसिडेंट. दिस इज द डिफरेंस व्हेन यू सिंक्रोनाइज. सो यू कैन रिप्रेजेंट सिंक्रोनाइजेशन यूजिंग एक्टिविटी डायग्राम्स. Okay ji. Now let's formally look at the fork nodes and the joining nodes. Fork nodes, they split flows into multiple concurrent flows. Okay ji. ये याद रखें कि these are concurrent flows. These represent basically you now have splitted the flow. लेकिन एक चीज़ जो important है कि ये दोनों active हैं अब. ठीक है. यानी कि जब आपने fork लगा के split किया तो आपको order receive हुआ, you're filling the order, you're shipping the order, at the same time you're sending the invoice and dealing with the payment. Okay, so these things are happening in parallel. ठीक है. This is something related to UML 1.5 that state machine forks in UML 1.5 required synchronization between parallel flows through the state machine RTC step. UML 2.0 activity forks model unrestricted parallelism. ठीक है. From 2.0 ये जो fork models है इनके थ्रू आप unrestricted parallelism represent कर सकते हैं अपनी activity diagrams के अंदर. ओके जी, एंड देन वी हैव, हमने इनको पहले भी डिस्कस किया है, और ज्वाइनिंग के थ्रू हम क्या करते हैं, ज्वाइनिंग के थ्रू वी अचीव सिंक्रोनाइजेशन, ठीक है, दिस इज वेरी इंपॉर्टेंट। स्प्लिट करने के लिए वी हैव फोर्क नोड्स, एंड व्हेन वी नीड टू सिंक्रोनाइज वी हैव these join nodes. So what do we achieve with these join nodes? You can see that there are multiple inputs coming to these join nodes, ठीक है, and what do we do at the join node? We are basically waiting for all these inputs to arrive, and only then we will basically move, or we will pass the control to the next action. जिस तरह for example ship order और accept order है, we will wait here until both of them are done, and then we will close the order. So this is important. यानी कि आपका ये काम उस वक्त तक पूरा नहीं होगा जब तक इन दोनों के ऊपर आपको वैल्यूज रिसीव नहीं हो जाती, ठीक है, एंड विच मेक सेंस कि जब तक आपका ऑर्डर कुछ शिप ना हो जाए या कस्टमर को पहुंच ना जाए या वो आपको उसकी पेमेंट रिसीव ना हो जाए, तब तक अपने सिस्टम के अंदर उस ऑर्डर को क्लोज नहीं करेंगे। अदरवाइज फॉर एग्जांपल आपका ऑर्डर शिप ही नहीं होता और आपने ऑर्डर को क्लोज कर दिया, तो कस्टमर आपको कॉल करके पूछ रहा है कि व्हाट इज द स्टेटस ऑफ माय ऑर्डर, बट यू डू नॉट हैव एन आंसर टू दैट। सिमिलरली अगर आपने शिप कर दिया और आपकी पेमेंट नहीं आई, फॉर एग्जांपल क्रेडिट कार्ड जो कस्टमर ने आपको नंबर प्रोवाइड किया था, हिज लिमिट वाज फुल और व्हाटएवर वाज द रीजन, लेकिन अगर आप उस ऑर्डर को क्लोज कर देंगे शिप करने के बाद, तो आपकी कंपनी के जब आप आखिर में दिखेंगे कि आपको कितने ऑर्डर आपने भेजे हैं और आपको पैसे कितने मिले हैं, तो देयर विल बी अ डिफरेंस इन द एंड। सो दैट्स व्हाई वी नीड टू सिंक्रोनाइज दिस एक्टिविटी, एंड वी कैन रिप्रेजेंट दैट यूजिंग दीज जॉइन नोड्स इन द एक्टिविटी डायग्राम. Okay, generally the controls or data must be available on every incoming edge in order to be passed to the outgoing edge, but user can specify the different conditions under which a join accepts incoming controls and data using a join specification. Okay, so basically normally if you do not have any specification condition at join, ठीक है, तो द स्टैंडर्ड इज कि ये सब के लिए इनपुट का वेट करेगा एंड देन इट विल पास, बट यू कैन स्पेसिफाई द रिलेशनशिप. जिस तरह फॉर एग्जांपल हियर यू हैव एन एक्टिविटी जहाँ पे आप कह रहे हैं फाइल प्रॉब्लम रिपोर्ट, ठीक है जी, यू हैव हियर प्रायोरिटी 1 है, तो यू आर डूइंग इवेलुएट इम्पैक्ट, रिवाइज शेड्यूल, एंड देन यू कम हियर ए फ्लो आ गया और आपका ये बी फ्लो आ गया. वेयर एज इफ यू हैव दिस प्रॉब्लम, यू फिक्स द प्रॉब्लम, यू टेस्ट द फिक्स, एंड देन यू हैव सी. ओके, सो आपके बेसिकली क्या है, देयर आर टू सेट्स ऑफ एक्शंस, ठीक है, एक के अंदर आप उसके इम्पैक्ट को एवेलुएट कर रहे हैं और रिवाइज कर रहे हैं. बेसिकली द होल पॉइंट ऑफ दिस एक्टिविटी डायग्राम इज कि यहाँ पर अगर आप ये देखें कि ज्वाइन करते हुए हमने स्पेसिफाई कर दिया है कि यू विल पास टू दिस रिलीज फिक्स इफ इट्स ए और बी एंड सी, ठीक है, यानी कि आइदर ए शुड बी देयर और बी शुड बी देयर, आइदर वन फ्रॉम ए और बी एंड सी. जब इन तीनों में से, इन दोनों में से कोई एक और सी होगा तो वी विल गो टू रिलीज फिक्स, ठीक है. दिस इज समथिंग इंपॉर्टेंट. और अगर हमने यहाँ पे ये ना लिखा होता तो इट वुड हैव वेटेड फॉर ए बी एंड सी, ठीक है, विच वाज बेसिकली नॉट पॉसिबल इन दिस केस, क्योंकि आपका ये डिसीजन बॉक्स फ्लो को दो में डिवाइड कर रहा है. ओके, सो वी कैन स्पेसिफाई कि हमारा ज्वाइनिंग की क्या क्राइटेरिया होगा, ठीक है, तो वी कैन ऑल्सो डू दैट. एंड व्हेन वी डू दैट, तो वो पर्टिकुलर जो हमने ऑर्डर डिफाइन किया, जो भी हमारी कंडीशन है, व्हेनेवर दैट इज सेटिस्फाइड, तो वी पास द फ्लो टू द नेक्स्ट वन. ओके जी, नाउ मूविंग ऑन टू द फाइनल फ्लोज और द फ्लो फाइनल. ये जो हमारा एक सर्कल है जिसके अंदर क्रॉस लगा होता है, ये रिप्रेजेंट करता है कि हमारा फ्लो यहाँ पे जाके खत्म हो गया. वी हैव ऑलरेडी सीन इन सम ऑफ द एग्जांपल्स दैट वी हैव सीन. और जैसे जैसे टोकन्स इसके पास आ जाते हैं तो द टोकन्स आर डिस्ट्रॉयड. इट बेसिकली डिस्ट्रॉयज द टोकन्स दैट अराइव ऑन टू इट. द एक्टिविटी इज टर्मिनेटेड व्हेन ऑल द टोकन्स इन द ग्राफ आर डिस्ट्रॉयड. फॉर एग्जांपल आपका ये वाला जो फ्लो है, द ऑर्डर इज रिसीव्ड, आपने फिल किया ऑर्डर, शिप किया ऑर्डर, इनवॉइस की, पेमेंट रिसीव की, और यहाँ पे आपका ये सारा काम खत्म हो गया, ठीक है. यानी कि अगर हम एक अपने ऑर्डर मैनेजमेंट या ऑर्डर का हमारा बिजनेस का क्या प्रोसेस है उसको हम मॉडल करना चाह रहे हैं, तो जब आपका ऑर्डर शिप भी हो गया और आपने अकाउंट को पे भी कर दिया, तो आप यहाँ पे आखिर में ये वाली नोट डाल रहे हैं जो कि आपकी फाइनल नोट कहलाती है, जो रिप्रेजेंट करती है कि यहाँ पे आपका काम खत्म हो गया. ओके जी, देन देयर इज अ कॉन्सेप्ट ऑफ फाइनल नोट. फाइनल नोट क्या कहती है, द एक्टिविटी इज टर्मिनेटेड व्हेन द फर्स्ट टोकन अराइव्स, ठीक है, यानी कि जैसे ही आपको पहला टोकन मिल जाता है, ठीक है, तो देयर इज अ डिफरेंस. जो फ्लो फाइनल है वो कहता है कि फ्लो वेट करता है जब तक कि सारे टोकन उसके पास नहीं आते, एंड देन यू से दैट द एक्चुअल द फ्लो इज फिनिश्ड. वेयर एज जो फाइनल नोड है इट वेट्स फॉर आइदर वन ऑफ देम, ठीक है, यानी कि जैसे ही पहला टोकन आता है तो वो खत्म हो जाता है. जिस तरह इसी रिसीव ऑर्डर को अगर हम डिफरेंट तरह से मॉडल करें कि अगर तो ऑर्डर एक्सेप्ट हो गया, यू फिल द ऑर्डर, यू शिप द ऑर्डर, एंड देन यहाँ से अगर आपके पास इनपुट आ गई तो देन यू एंड. वेयर एज इफ द ऑर्डर इज रिजेक्टेड, आप कस्टमर को नोटिफाई करते हैं, तो जैसे ही दोनों में से कोई एक आएगा, आइदर आपने ऑर्डर रिजेक्ट किया, आपने कस्टमर को बताना है कि जी आपका ऑर्डर रिजेक्ट हो गया, तो आपका फ्लो खत्म हो गया, और आपने शिप कर दिया तब आपने कस्टमर को बताना है. सो देयर इज एन ऑप्शन हियर, वेयर एज इन द अबव केस इट वुड वेट, क्योंकि यहाँ पे हम यहाँ पे हम मॉडल ही डिफरेंट चीज़ कर रहे हैं, ठीक है। यहाँ पे फॉर एग्जांपल हम ये वाली चीज़ यूज़ नहीं कर सकते, व्हाई नॉट, क्योंकि हमें वेट करना है दोनों तरह के टोकन्स का, हमने ऑर्डर के शिप होने का भी वेट करना है और पेमेंट रिसीव करने का भी। लेकिन जो ये वाला केस है इसके अंदर हम सिर्फ ये बता रहे हैं कि ऑर्डर एक्सेप्ट हुआ या रिजेक्ट। जब एक्सेप्ट हो गया तो हमने ये यूज़ कर लिया, रिजेक्ट हो गया तो ये यूज़ कर लिया। So in this slide we have seen the difference between the flow final and the final node. So final node says that अगर आपको एक भी flow से एक भी टोकन मिल जाएगा, जैसे ही पहला टोकन मिला तो your flow is ending. Whereas in case of flow final आप सारे टोकन्स का वेट करते हैं, जैसे जैसे टोकन आते जाते हैं you keep on destroying them and then you say कि हमारा flow खत्म हो गया। Okay जी, that's about it that we will cover in today's lecture on activity diagrams. And let's quickly summarize कि हमने आज के लेक्चर में क्या देखा। We basically learned a lot of interesting stuff about activity diagrams, ठीक है। पहली चीज़ तो हमने देखा कि activity diagrams को हम क्यों यूज़ करते हैं, ठीक है। पहली बात तो ये हमने कहा कि जी activity diagram is kind of a flow chart, ठीक है। लेकिन what is special about activity diagram is that it can be used to represent the parallel behavior, ठीक है। यानी कि parallel आपने जब एक्शन करना है तो हमने देखा कि हम activity diagrams को यूज़ करके वो हम रिप्रेजेंट कर सकते हैं। Secondly, we saw कि activity diagrams किस लिए यूज़ होती हैं। They are used to basically analyze use cases, या आपने transitions different use cases के दरमियान workflow को understand करना है and then you can use these activity diagrams, ठीक है। Then moving on, we saw different examples of activity diagrams, and in this lecture basically what we have tried to develop an understanding that what are the different elements involved और कौन सा element कहाँ पे use करना ज़्यादा बेहतर है, ठीक है। We saw different kinds of nodes in this. एक तरह की जो हमने नोट देखी उनको हमने कहा कि वो हमारे एक्शंस हैं, ठीक है। दे आर नॉर्मली रिप्रेजेंटेड बाय दीज राउंडेड रेक्टेंगल्स और उसके अंदर हम उसका नाम लिख देते हैं, ठीक है। फॉर एग्जांपल फिल ऑर्डर, ठीक है। दिस वाज वन काइंड ऑफ अ नोट। फिर हमने एक और तरह की नोट देखी जिसको हमने कहा ऑब्जेक्ट नोट, ठीक है। इट कैन आइदर बी हेयर या ये पिन्स की फॉर्म में आप इस तरह भी हो सकते हैं, तो दे आर द सेम थिंग। ये कौन सी नोट्स हैं आपकी? ऑब्जेक्ट नोट्स। ऑब्जेक्ट नोट्स क्या करती हैं कि व्हेनेवर there are some parameters, कोई data or an object is passed between two actions or two activities, तो वो this is basically that goes through these object nodes, या object nodes hold that data basically. Then we saw कि we have some control nodes, और control nodes के अंदर हमारी different types हैं। We have control nodes, उसके अंदर एक हमारी control node है जिसको हमने कहा कि इसको हम क्या कहते हैं, either these are decision के लिए ये यूज़ करते हैं या हम मर्ज करने के लिए लिंक्स को यूज़ करते हैं। फिर एक हमारी होती है ये जिसको हम किसके लिए यूज़ करते हैं, या तो वी यूज़ देम फॉर फोर्किंग और फॉर ज्वाइनिंग। जब फोर्किंग के लिए यूज़ होती है, ओके, इसको हमने देखा था कि जो हमारा डिसीजन बॉक्स है ये किस लिए यूज़ होता है कि आपके पास कोई ऑप्शंस यहाँ पर आई, ठीक है, और इफ़ यू हैव टू टेक वन डिसीजन यू टेक दिस पाथ, इफ़ यू टेक अनदर डिसीजन यू टेक दिस पाथ, और आप इनके साथ गार्ड स्पेसिफाई कर सकते हैं कि कौन सी कंडीशन में इधर आना है, कौन सी कंडीशन में इधर आना है। यही वाली आपकी कंट्रोल नोड डिफरेंट मल्टीपल एक्टिविटीज़ को अगर आपने एक जगह पे जोड़ना है ये इसके लिए भी यूज़ हो सकती है। लेकिन इसके अंदर प्रॉब्लम क्या है कि इट विल नॉट सिंक्रोनाइज देम। जैसे जैसे इसको किसी भी फ्लो से टोकन आते रहेंगे ये आगे पास करते रहेगी, आउटपुट करती रहेगी, ओके। देन वी सॉ टू अदर काइंड्स ऑफ नोड्स, कंट्रोल नोड, जिसको हमने कहा एक को फोर्क और दूसरी को हमने कहा ज्वाइन। फोर्क किस लिए होता है कि आपकी एक्टिविटी एक आ रही है और उसको आपने मल्टीपल जगहों पे पास करना है, ठीक है। तो यू आर बेसिकली स्प्लिटिंग। जिस तरह आपको ऑर्डर मिला, हमने रिसीव ऑर्डर वाली एग्जांपल बार बार देखी है, यू रिसीव्ड एन ऑर्डर, तो देयर आर टू सेट्स ऑफ एक्शंस। एक के अंदर आपको उस ऑर्डर को शिप करना है और दूसरे के अंदर आपको इनवॉइस भेजनी है और पेमेंट रिसीव करनी है, तो यू आर डूइंग बेसिकली मल्टीपल एक्शंस, ठीक है। और लेकिन आखिर के अंदर जब आपने इस ऑर्डर को क्लोज करना है तो उससे पहले हमारी क्या कंडीशन है कि वी नीड टू वेट कि आपका ऑर्डर शिप भी हो चुका हो और हमारा ऑर्डर क्या हो गया हो, उसकी हमें पेमेंट भी मिल गई हो। तो उस केस के अंदर क्योंकि हमें इसको सिंक्रोनाइज करना है तो सिंक्रोनाइजेशन के लिए सेम रिप्रेजेंटेशन है लेकिन वी कॉल इट ज्वाइनिंग। तो ज्वाइनिंग के अंदर क्या होता है कि जब तक इन दोनों में से नहीं आएगी तब तक हम आगे नहीं जाएंगे। लेकिन एक और चीज़ जो हमने इंटरेस्टिंग ज्वाइनिंग के अंदर देखी कि हम यहाँ पे स्पेसिफाई भी कर सकते हैं। फॉर एग्जाम्पल हमारी ज्वाइनिंग ऐसी थी कि उसमें ए और बी हो सकता था, तो वी कैन से ए और बी, लेकिन फिर यहाँ पे खैर ज्वाइनिंग की ज़रूरत नहीं होगी। उसकी हमने एक पर्टिकुलर एग्जाम्पल देखी थी कि फॉर एग्जाम्पल वी हैव समथिंग लाइक दिस, वी वेंट हेयर और यहाँ पे हमारा एक डिसीजन बॉक्स था, इसकी बेस के ऊपर हमने एक एक्शन लिए या हमने एक और तरह के एक्शन लिए, ठीक है। और एक और हमारा यहाँ से सेट ऑफ एक्शन चलते चलते आए और यहाँ पे हम पहुँच गए। तो इनको हमने कहा ए, बी और सी, यानी कि तीन तरह की हमारे पास आ सकती हैं, आइदर ए से फ्लो में आएगा या बी से कोई इनपुट आएगी या सी से आएगी। लेकिन क्योंकि यहाँ पे डिसीजन है तो ऑब्वियसली इन दोनों में से एक ही एक्टिव होगा, तो हमारी यहाँ पे स्पेसिफिकेशन क्या बन जाएगी, ए और बी एंड सी, यानी कि ये सिंक्रोनाइजेशन का वेट करेगा सी का या इन दोनों में से किसी एक का। जैसे इन दोनों में से कोई एक और सी मिल जाएगा तो आप आगे चले जाएंगे, ठीक है। जब तक सी नहीं आएगा या इन दोनों में से कोई एक नहीं आएगा तब तक आप आगे नहीं जाएंगे। सो वी कैन स्पेसिफाई द ज्वाइनिंग बिहेवियर इफ इट्स पर्टिकुलर। देन वी ऑल्सो सॉ कि हमारी इनिशियल नोड क्या होती है। इनिशियल नोड की हमारी रिप्रेजेंटेशन कैसी होती है। इनिशियल नोड इज समथिंग लाइक, जो एक सॉलिड सा हमारा सर्कल होता है, वी कॉल इट इनिशियल नोड। और इनिशियल नोड के हमने ऊपर देखा था कि इनिशियल नोड फौरन से कंट्रोल जो है वो अगली एक्टिविटी को फॉलो कर देती है, लेकिन ये टोकन्स को डुप्लीकेट नहीं कर सकती। दिस इज समथिंग इंटरेस्टिंग एंड इंपॉर्टेंट। फिर हमने दो तरह की और कौन सी नोड्स देखी हैं। एक को हमने कहा था फ्लो फाइनल और एक को हमने कहा फाइनल नोड। फाइनल नोड क्या करती है, जैसे ही पहला टोकन रिसीव हो जाता है आपका फ्लो खत्म हो जाता है, जबकि जो फ्लो फाइनल होता है वो सारे टोकन्स का वेट करती है, जब तक सारे टोकन नहीं आते तब तक वो उसको खत्म नहीं करती। देन वी सॉ एजेस। एजेस क्या करते हैं, बेसिकली आपकी ट्रांजिशन को रिप्रेजेंट करते हैं बिटवीन डिफरेंट एक्शंस, ठीक है जी। So this is what we have covered in today's lecture. We have discussed different kind of elements that are involved in activity diagrams. There is still more to come in activity diagrams and we will continue with that in the next lecture. Until then, take care and Assalamu alaikum.